Assalamu alaikum. Today I am going to discuss about Edexcel IGCSE Certificate in Physics, Unit 3, Chapter 13, Sound. I am Jahangir. I am a physics teacher. First we have to learn about what is sound wave. Sound is produced by a vibrating object. When any object vibrate, then we hear sound. So sound wave consists of mechanical vibration in air and other substances. So sound wave is a mechanical wave because sound wave needs physical medium or mechanical medium for its propagation from one place to another place. Sound cannot travel through vacuum. Sound is a longitudinal wave. What is longitudinal wave? If the direction of vibration of the medium particles is parallel or same direction or zero angle with the direction of propagation of the wave is called longitudinal wave. Sound is a longitudinal wave because the direction of vibration of the air molecules or medium particles are to and fro here, compression and rarefaction, and sound wave propagate parallelly with the direction of vibration. That's why sound wave is a longitudinal wave. Look at this diagram. Through air, a sound wave consists of a series of compression and rarefaction. Compression is a region of slightly higher pressure where the air molecules are closer together than the usual. Rarefaction is the opposite. That means here molecules are far away from each other. The wavelength of the sound wave is usually the distance between the centers of the two successive compression. Range of hearing. Human brain can hear sound frequencies in the range 20 Hz to 20,000 Hz. Age and damage reduces the upper limit. For example, an old person or someone exposed to the prolonged high sound volume may no longer be able to hear above 10,000 Hz. Some animals can hear much higher frequencies, bats and dolphins up to 1 lakh Hz. Dog 40,000 to 60,000 Hz, depends on the breed. Now, ultrasound. Ultrasound is a high frequency sound. If the sound wave has a frequency more than 20,000 Hz, is called ultrasonic sound or ultrasound. So above 20,000 Hz too high to be heard by humans. Ultrasound echo can be used to measure distance, example sonar, to see the inside the object. We can scan any inside the body. Infrasonic sound is low frequency sound. If the sound wave have a frequency less than 20 Hz is called infrasonic sound or infrasound. Infrasonic sound also inaudible to human, although we may feel the very slow vibration, but we cannot hear the sound. Earthquake waves are a form of infrasound. Elephant and some other large animals can hear infrasonic sound. Sound wave in different materials. Sound travels quickest through solids. A train can often be heard approaching through the rails track before it can be heard through the air. Sound travels well through liquid. Whales can communicate over great distance underwater. Sound travels slowest through gases. The speed of the sound increases with temperature. So, speed of the sound increases if temperature increases. Sound does not travel through vacuum. That's why sound wave is a mechanical wave. Sound does not travel in space. There is an experiment well-known experiment. It is bell jar experiment. Look at the diagram here. This experiment shows that the sound needs a material medium for transmission. As the air pressure inside the bell jar is reduced, the loudness of the sound heard outside decreases. The bell can be still seen to be working normally, but we cannot hear anything from the outside because all air molecules removed by the vacuum pump. If air molecules removed from the vacuum pump, then we cannot hear sound. Now, reflection of sound. Reflection of sound is known as echo. So, if sound wave reflect back to the listener or human ear after 0.1 second persistent time of our human brain, then we can recognize this reflected sound separately from the direct sound. Then that reflected sound is known as echo. We use this reflected echo sound to measure the distance, measure the speed of the sound in air medium. Question: a misguided child shouts Chelsea at a nearby cliff and hears an echo 1.4 seconds later. How far away is the cliff? Take the speed of the sound 340 meters per second. We know speed equal to distance divided by time. Here distance, echo sound or reflected sound travels twice distance. So distance equal to speed into time. 340 meter per second into 1.4, because reflected sound travels twice distance, we have to half the time. So 1.4 second, so 476 meter is the twice d. Distance to the cliff is 238 meter. Sound refraction. What is the meaning of refraction? First we have to learn about what is the meaning of refraction. When any wave passes from one dense medium to another denser medium, then it changes its direction of path. This phenomenon is known as refraction. So refraction means bending of any type of wave. Sound produced by the person A may be heard more clearly by the person B than by the person C. Why? The cooler air over the water refracts the sound waves downwards. That's why the person A may be heard more clearly by the person B than by the person C. Sound diffraction. First we have to learn about diffraction. What is the meaning of diffraction? When any wave passes through a narrow gap, then it is spread out. This phenomenon is known as diffraction. A typical sound wave has a wavelength of about 1 meter. This is the similar in size to the aperture of the doorway. Therefore, sound undergoes significant diffraction at a doorway of the or around the corner of the building. This is why we can hear someone in such circumstances even though we can not see them. Why does light not diffract as much as sound? Because wavelength of the light is about 0.0005 millimeter, much smaller than the door aperture. That's why light cannot be seen, but we can hear the sound. Measuring the speed of the sound by direct method. Measuring the speed of the sound directly between 2 points. Method number 1. Two people stand at a distance about 100 meters apart. The distance between them is measured using a trundle wheel or measuring tape. One of the people has two wooden blocks which he bangs together above the head. The second person has a stopwatch which he starts when he sees the first person banging the block together and stop when he hears the sound. This is then repeated several times and an average value is taken for the time. The speed of the sound can be calculated using the equation speed equal to distance traveled by the sound divided by time taken. Second method, measuring the speed of the sound using echoes. A person stands about 100 meters away from the wall or any cliff. This distance is measured using a measuring tape or trundle wheel. The person claps two wooden blocks together and listen for the echo. The person then start to clap and the blocks together repeatedly in a rhythmic way with the echoes. The second person has a stopwatch and start timing when he hears one of the claps and the stop timing after 20 claps later. The person is then repeated and average time calculated. The distance travel by the echo is twice, because reflected sound first goes to wall and reflects back. That's why it travels twice distance. So speed equal to distance divided by time taken. Here distance is twice d and time taken is t, so twice d divided by t. So speed equal to twice d divided by t. But here the total distance by the sound during 20 claps, so 20 into twice 2d divided by t. Question, there is a mathematical question. A group of students measured the time taken between seeing and hearing another student 250 meters away. Clashing two pieces of wood together, they obtain the following timing in second: 0.73, 0.78, 0.69, 0.81, 0.77. Use their measurement to obtain the speed of the sound. Average time 0.73 plus 0.78 plus 0.69 plus 0.81 plus 0.77 divided by 5. So average time is 0.756. So speed equal to distance divided by time. So distance divided by time. So 250 into 2 divided by 0.756 second. So speed of the sound is 331 meters per second.